So this video features something called dimensional analysis, which is a unit conversion method that's very commonly used in chemistry. A lot of our most difficult problems that we're going to be solving will require us to use dimensional analysis. So we're going to start with some kind of generic problems that have nothing to do with chemistry, and look at how this can be used for both problem solving and unit conversion. So dimensional analysis can also be called factor label method commonly. There are a couple different ways to sort of write it out. It's essentially a conversion method that's used a lot by scientists and engineers, and you, at some point in math, will cover this as well. So a conversion factor, or conversion fraction, is actually a fraction that is equal to 1. So even though the numbers in it don't appear to be equal to 1, they use equivalent quantities. So if we want to write a conversion factor, conversion fraction, you can call it either one, we could say, all right, if we want to convert between milliliters and kilometers, a factor that we could use is we could say there are 1,000 meters in 1 kilometer. Or we could say there is, if we have 1 kilometer, it contains 1,000 meters. Now, neither of these are mathematically fractions that would say, oh, that's the same number on top and bottom, that's 1. But because these are equivalent values, these are actually fractions that are equal to 1, which means we can multiply them by anything we feel like. So if we wanted to look at centimeters and meters, you'd say, okay, 1 meter is 100 centimeters. So you could either write 1 meter over 100 centimeters or 100 centimeters over 1 meter. So what's nice about this is, we can actually use these to convert units and solve problems, as I mentioned before. And we have a lot of flexibility in how we can use these, since we can flip them because they're equivalent to 1. So if we wanted to look at converting the 15-kilometer mountain goat race into miles, we would say, okay, so this problem is telling us that 1 mile is 1.61 kilometers. In this particular problem, I'm going to kind of ignore significant figures a little bit. I have 2 potential conversion factors here. I can put 1 mile over 1.61 kilometers, or I can put 1.61 kilometers over 1 mile. And the one that I'm going to pick is based on what I start with and what I end with. So next I'm going to look at my starting amount, which is 15 kilometers, and my desired ending unit. So what I want this to come out in is miles. Now for this particular question, this is a very simple question that you could probably solve without using this, but it's a nice way to illustrate how this method works. So what I want to be able to do is cancel out kilometers, and therefore converting it into miles. So since kilometers is on the top right here, I need to put some kilometers on the bottom. So I'm going to go ahead and select this conversion factor, and I'm going to write in 1 mile over 1.61 kilometers. Kilometers are going to cancel. So what I'm really doing here, these are often shown as parentheses and fractions. I'm saying 15 kilometers times 1 mile over 1.61 kilometers. So that's really typically how this is set up. I just kind of use this picket fence way of doing it. It's a little bit quicker to write usually. So mathematically what you're doing is punching in 15 times 1, which is 15, divided by 1.61, and treating this like a giant fraction, and you get 9.3 miles. And again, I took a little liberties with the sig figs there, but if you kept 2 sig figs from the 15 kilometers, assuming that the mile is kind of an exact number, you get 9.3 miles. If we want to do a conversion, we can say, okay, I've got centimeters and I want to go into kilometers. Now, you may know offhand exactly how many centimeters are in a kilometer, but I don't. So what I'm going to do is a 2-step problem, where I'm going to say, okay, I know that 1 meter has 100 centimeters. I could also write 100 centimeters over 1 meter. I can relate kilometers to a meter by saying 1 kilometer equals 1,000 meters, or 1,000 meters equals 1 kilometer. Little note up here, what's really nice about this is metric conversions are exact numbers. It's a real advantage of the metric system when you're doing any of this type of problem solving. No metric conversion factors will ever limit your number of sig figs. So my starting amount is going to be 2,456.2546 centimeters. And I want this to end up in, kilometers. And I'm going to do this as a two-step problem because I don't offhand necessarily know how many centimeters are in a meter. I can figure it out, or in a kilometer. I can figure it out quickly, but this is a nice way to do it pretty accurately. So my goal first is to get rid of centimeters. So I have centimeters right here. I need centimeters right here to cancel things. So this conversion factor right here lets me put 1 meter over 100 centimeters, which will allow me to cancel my centimeters. In my next conversion factor, I have meters on top, and I need them to cancel. So I'm going to choose my conversion factor that puts meters on the bottom. Oops. Sorry. 1,000 meters and 1 kilometer. I can then at this point cancel out my meters, and hey, I'm left with kilometers. That's exactly what I wanted. So then you're going to do 2,456 times 1 times 1, so just 2,456, and you're going to divide it by the product of 100 times 1,000. And this gives us 0.0456 kilometers. We had 4 sig figs in our starting number. We were not limited at all, so I kept all 4 of those significant figures. Another way of writing this I mentioned before is with parentheses. So if you see someone in college doing these problems, they tend to have a setup that looks a little bit more like this. So they're actually using parentheses with fractions in them. That's another way to do this. Looks a little bit different. I just think the line is nice, and you can add factors really easily and quickly. So a couple of examples here for you to look at in terms of conversions. So if we want to convert meters to kilometers, we're going to put down first our starting amount, which is 943 meters, and we know we want to end up in kilometers. So this is nice, this is a straight up conversion factor. I'm just going to show this in parentheses this time. If we put 1 kilometer on the top and 1,000 meters on the bottom, our meters will cancel. This helps me remember a lot of students are like, oh, I know it's 1,000, but do I divide or multiply? The nice thing about using dimensional analysis is that reminds you, that setup reminds you you're going to be dividing to get 0.943. If we want to figure out how many milliliters are in 5.4 liters, we're going to start, sorry, I like to write black. We're going to start with our 5.4 liters. I want liters to go away, so I'll put 1 liter on the bottom and 1,000 milliliters on top. My liters cancel. This reminds me, oh, liters and milliliters, I'm going to multiply. 5,400 milliliters. And again, I put that space there rather than the comma, but if you have the comma there, that's totally fine. I did keep sig figs consistent in these. 943 has 3, so my answer did. And 5.4 has 2 sig figs, so 5,400 with no decimal there is 2 sig figs. If you put a decimal at the end, you added sig figs. If I want to do centimeters to kilometers, or kilometers to centimeters, sorry. And I'll show this one with the line. This is a 2-stepper, or I would do it as a 2-stepper. So 0.67 kilometers. And if I know I'm going to do 2 steps, this is kind of a quick and easy way to do this. 1,000 meters to 1 kilometer. And sometimes I like to kind of cross things off as I go along. So I chose that factor because kilometers is on the bottom, and we'll allow that to cancel. To get my meters to go away, I put a meter on the bottom, and that's equivalent to 100 centimeters, which is what I want my answer to come out in. So I'm just multiplying straight across the top to get 6,700 centimeters. And one more of these, if we had 456 milliliters. Milliliters and liters is a commonly done conversion in chemistry. If I want to get rid of my milliliters, I do so by putting them on the bottom. Oops. And what I'm doing here is dividing. I'm going to actually stop this video and do a separate video for the use of this as a problem-solving technique. So make sure you check out that video. We'll walk through some problem solving and have some examples you can try on your own.